That's our height. All right, we ready?
The other angle of attack is really a bunch of hydration, right? My name is Stephanie Allen. I'm Jennifer Green.
Keith Katie. Nicholas Schwartz.
And I'm Lowell.
All right, so we have the apparatus here with just a bucket and a shelf on it out of my house, and then just wood and stuff. But we used like a small diameter pipe so that we could really show like a good head loss in the pipe. And then the small diameter of the pipe compared to the large volume of the bucket means that the surface of the water here is going to drain pretty slowly, so the velocity here is going to be pretty negligible. And we assumed that the height of the water, the change in the height of the water was negligible. So basically, once we do that, you'll be able to actually see the hydraulic grade line, and then we're going to trace that with this string here. And from that, basically we're able to calculate a few different things, like where the EGL is and the velocity of the water, which I'll explain after we start it. So I guess that's it. Okay, start this going. All right. So now you can see the difference in heights. We didn't use colored dye, so hopefully you can see it, but it clearly goes down, and it's pretty linear. One reason it might not be linear is because this pipe is a little curvy, but so basically, one thing we did to calculate where the EGL was we measured the height of the water in the bucket, and then we measured the height of where the string met the bucket. The difference in that height was where the EGL was, and that gave us the velocity head. So from there, we were able to calculate the velocity of the water using Bernoulli's equation, basically just the velocity head, v squared over 2g. We used that height there, and then it was just v equals the square root of 2gh. Now, we wanted to check that too, just to see how accurate the equation was. I'm going to stop that before it overflows. We wanted to check that. So what we did was we used this measuring cup, and we took a stopwatch. And then as the water started flowing in here, we timed it, then we did it up to 1 liter and 2 liters, and we averaged the time. So we had the volumetric flow rate, so how many liters per second. And then dividing that by the cross-sectional area of the tube, that gave us the actual experimental velocity of the water coming out of the tube. So we compared that to the velocity we got using Bernoulli's equation over here with the EGL, and they were actually very close. They were only, what was it, like a 3.5% error or something like that. It was only like 0.03 meters per second off. The velocity ended up being like 0.8 meters per second, something like that. I guess that's it. Okay, this is the one person. All right. This is where that practice came in. Oh, you're gonna get wet.